Hello friends, welcome to our new problem statement, and that is Geeks for Geeks problem. Our problem is minimize max distance of gas stations. It is medium level. It is hard level Geeks for Geeks problem. So let's say what is question statement saying. Before reading the question, we will understand that how we will solve the question. First of all, we will learn or understand the problem statement and input and output. Then the identify our questions, then how can we solve it. Then after it, we will explain its identifications, then we code it, and after you can try run of the question. So let's say what is the problem statement is saying. We have a horizontal number line. On that number line, we have gas station at positions station of 0, station of 1, and so on and minus 1. So in if you see this example, you can see that here are the gas station 1, 2, 3, 4, and 5. 5. Okay. Now we add a K more gas station so that D, the minimum maximum distance between adjacent gas station minimized. So our question is saying that we have two more gas station to add between or outside, so that the distance between the gas station we can minimize it. So next, let's say what the question saying, we have to find the smallest possible value of d. That we want to smallest possible value of d will be the distance of minimum distance that we will placed after the k gas stations. Find the exact answers of six decimals. It is the our constraint of the questions that we can find out. We have to find the answer up to six decimal places. Keynote here the station is strictly increasing order. That means the station will be in sorted order, and sorted will be like increasing order. Okay. So before starting this questions, let's take a example. Let's let a example before taking another example, we can discuss it. So here is the gas station at position 1, 2, 3, and 4 and 5. We have gas station 2. We have to place in between or outside these stations to so that we can minimize the between the station distance. So let's see, the distance between 1 and 2 is 1, 2 and 3 is 1, 3 and 4 is 1, and 4 and 5 is 1. So all the stations have the equal distance. So we cannot put our new station in between them because we already have the minimum distance. Okay, so it is not logic to put inside our stations. So in this question, we should put the outside of this station. So next station will be at the sixth position and next one will be 7. Understood? So here main motive is to find the distance that is minimum so that we can minimize the distance between two stations. So the explanation also saying that since all gaps are already equal and adding extra station in between does not reduce the maximum distance. Okay. So let's take another example for better understanding of our problem statement. So station is our array. Okay. Before starting this, we will code in our JavaScript. So here in not here we are not doing the code. We just understanding our problem. So let's take our problem example 1, 13, 17, and 23. This is our example of problem statement. Let's see that how we can add our new gas stations. The main motive is to minimize the distance between these any of them, any of two stations. Okay, so let's see. So what is the distance between 1 and 13 positions? Here is the distance is 13 minus 1 is equals to 12. Okay. Mhm. Here our distance is 12. Here is distance, our distance is 17 minus 13 is 4. And here distance is 23 minus 17 is equal to 6. That means where we can put our new gas stations. By the way, we have to put our gas stations, 5 new gas stations. Okay, so let's take a fast gas station. Where can we put the fast gas station in these places? So we have to give, we have to main motive is to minimize the distance between two gas stations so that we can we can minimize the distance. So here the maximum distance is 12. For the minimize the distance, we have to put the new gas station that where put the new gas station where the distance is maximum. So our first gas station will be put over here because these two gas stations have the maximum distance. Okay, so but our main motive is to that where can we put the for our fast gas stations. So fast gas station will be put by the its gap. Gap is 12 and 12 by 12 by 1. 12 we can we put the if we put our one gas station then gap will be gap will be become 2. Then so gap will also be equal for both. So our first question will be put looks like that, like first gas station and at seventh position gas station and next 13 position gas station and after it 17 position and next 23. So here you can clearly see that our gap, our new gap between the first and second distance will be here. This gap is 6 and also here the gap is also 6. So that we have put the first gap station and the become gap equal gap that is 6. New gap is 6. Then here we already know that the gap is 4 and next gap is 6. So we have put our gas station first gas station has been put and we have to put we have to put our 4 more gas station because one have been put. So how can we put our new gas station? So our new gas station will be put where the distance will be maximum. Understood? So here the station first first distance is 6 and second will be 6. Third will be 4 and 6 next one is 6. So here we can say that the at initial position the distance is maximum is 6. Okay, so we can put the next gas station over here. So over here, so we can divide the new gas station in between that. But we have not put our new gas station between 1 and 7 because the distance between 1 and 13 can be vary. So that initial position we have to get, the gap 12 we had the gap 12 and we have to put our two gas station. If we divide our two gas station then then gap will be 3. That looks like that our our let's see the example first. Our gas station X, our gas station Y, and our gas station Z. our gas station Z. Sorry, first of all, we have only two gas stations like F1 and 30. We have to put we have to put our new gas station in between them. So let first gas station here, second gas station here. Okay. When we put our two new gas station, then gap created between is 1, 2, and 3. Understood? That by this we can find our calculation that how can we find our equivalent, like gap is 12 divided by number of station 2 and plus 1, because gap is number of station plus 1. So our new gap should looks like first gas station over here. If we divide by 2 divide by 3, then we equal distance will be 4. So we have to put our the new gas station at fourth position, every fourth position. Okay, so first station will be over here, second will be fifth position, third will be ninth position, and fourth will be 13th position. Next have the same stations. Next have the same distance till now, and last one also have the 23. We have put our two gas stations till now. We have only three gas stations to put in between them. So here you can see that we have our gap is 4 here. We have 4 gap here. We have 4 gap here, and we have also 4. But here we have the gap in between 17 and 23 is 6. So we have to put our new gas station over here, because the maximum distance is over here, and we have to minimize our maximum distance. So we will put our new gas station over here, because the distance in between them is maximum. So we have the three gas stations, and our new gas station will be put 17 and 23, in between 17 and 23. So first over here, and second at fifth position, third will be ninth position, third will be sorry fourth will be 13 position, fifth will be 17 position, and sorry 17 position, and we have to put our new gas station in between them. So we have put like new gas station is X. In last position we have 23. So what should be the gap in between them? So here gap should divide equal. We have to divide our gap distance 6 into 2 equal distance. Our gap is, if we put one gas station, then gap will be created by 2. So we will divide by 6 by 2, then 6 divided by 2 is equal 3. So next gas station will be at the after third position, that means 17, 18, 19, and 20. So we will be create a 20th position will be new gas station, and we have only two gas station to put in between them. So here our gas stations. Now the let's calculate the distance between them, so we can put our two more two remaining two gas stations in between them. So first and second gas station have four stations. So second and third have fourth, third, fourth, and it's also four distance. It has it has three distance. So where we can put our new gas stations, because we can clearly see that First and second have the gap distance is 4. Okay, and no gas station have the more gap than 4. So we can put our new gas station in between 1 and 5th, 1 and 5th, but we will calculate our distance according to these conditions, because if we put here, then gap will be not remaining the same. So here our task, we have already put two gas station and we have to put our third gas station. So we have to put three gas station between 1 and 13. So before starting putting that, we can clearly see that our example. So first gas here. So second, let's example x, third y, and for z and fifth 13. So we have to put registration between 1 and 3. So what will be the gap will be created? So gap 1, gap 2, gap 3, and gap 4. Okay, we have 4 gaps and distance is equal to 12, because it is the distance 12. So at two distance we have to put our 3 gas region, that is 4 divided by 4, it equals 3. So that we have put our put our new gas station at every third place. Okay, understood? Every third place. So you can see that we our first gas station put, then 1 plus 3 is equal, our new gas station will be fourth. Our next one is at 7, next will be at 10, and next will be 13. So you can clearly see that we have been put our three new gas station in between, and all the station have the same distance, that is 3, and remaining 17 and the same 27 and 23. So here we have only one gas station to put in between them. So here you can see that 1 and 4 have the 3 distance, 4 and 7 have 3 distance, 7 and 10 have the 3 distance, and 10 and 13 have the distance is equals 3, and 17 and 14 has distance 4, and this one has 3 distance, and this one has 3 distance. So that we have only one station remaining, and we want to put the station in between them. So you can see that we have the maximum distance is 4. So our ultimate motive is to minimize the maximum distance, so that we have to put our new gas station over here at distance at 4. Okay, so our new gas station will be over here first at fourth position, second one at third position, there's third position at 10th and 13. Here you can see that we have to put our one gas station, but we have to put our one gas station, and or original one has zero gas station in between them. So we can put on simply over here, and if we put one gas station, then the distance gap will be created by 2, and the distance in between by 4. So 4 divided by 2 equals 2. So we will put every 2 distance, our new gas generator at every 2 distance. So next there will be 15 position, next has the 17 position, next has 20, and has 23 position, and all the stations have been put, so that here ultimate distance is here the 3 distance, here the 3, here we have 3 distance, here we 3, here we 2, here we 2, here we 3, and here we 3 distance. So our question is saying that find the equivalent text. We have to find the smallest possible value of d. So we have to find our distance in between that. That is the minimum. Minimum is the min min minimum distance is equals 3, sorry, 2, and max distance is equals 3 after putting all the five representations. So we have discussed its identification, problem statement, and explanation. So this is the brute force approach for these questions, and we can apply it to find the answer. But you can see that all our questions, all our test, most of test cases are passed. But because of it is brute force approach, and question is clearly saying that we have to find answer in n into log time complexity. So let's submit it that it's submit or not. So it's a runtime error because we have took the more time than we expected. The question is saying that we have to find the answer in n into log time complexity. So after next video we'll discuss its optimal solution by the binary search.